Thermal expansion is not a very intuitive idea because we typically think of our rigid objects in our world, basically all of our consumer products and our structures, as rigid bodies, so we don't think of them as moving. But in fact, if you think of it from a very atomic point of view, or even just a molecular point of view, then it's composed of very small structures which when heated are going to vibrate more rapidly, which is going to increase their overall volume. So the basic concept behind thermal expansion is that the greater the temperature, the greater the volume, or the size of your structure. So a simple example is if you have some kind of lid on a glass jar and it's really tight, what's probably the case is that as the temperature got colder, this metal lid was shrunk because of thermal expansion. So it's really hard to unscrew. And what you've probably learned through experience is if you dip this under hot water for a little bit, then it instantly becomes easy to unscrew. And what's happening is the radius of this lid is actually increasing because of thermal expansion. And there are formulas for this, but they're not important in understanding the concepts, which are actually quite a few when you get to structures. Take, for example, your basic sidewalk is probably paved. And while it might not be the original intent, actually these little cracks in here where you might see grass are actually very crucial, because on a very sunny day, and when these pavements get hot, they actually increase in their area, or the sides of these squares. And so these cracks actually get thinner. And this becomes very, very deliberate when you look at large, extremely rigid structures like freeways, especially highway overpasses, because those ideally are exactly the same length all the time. But of course on a hot day, these are going to expand lengthwise. So what you usually see on freeways is you see what seem to be like interlocking teeth, which normally are apart. But what actually happens is the hotter the day is, then these get closer and closer together. And the big problem is because if there weren't any of these, then these would get expanded in. But here, these are rigidly locked to the ground. So there's a force that these concrete columns need to exert inwards to counteract the thermal expansion here, which is often going to cause cracks right around these joints. So another example of this is in bridges. If you're trying to span some kind of canyon, with say like a steel bridge, which is about say 300 feet long, and say you built this in the wintertime when it was about 35 degrees Celsius, well maybe in the summer it's 90 degrees, this is actually going to increase by about 1.2 inches in length. And that might not seem like a lot, but in fact the property of steel is that if it has to counteract the force of its expansion because of these rigid cliffs, it actually loses half of its strength. So you get a serious structural problem here. So instead of building bridges that are stuck between canyons, engineers tend to build bridges that might have a rigid end, but the other side is free to move. And finally, we're going to look at, say you have a steel frame building, which has steel columns and steel beams. And the original intent might be something like this, which is all orthogonal. Let's say this side is a south-facing building, and during noon, the sun is really making this side of the building hotter. So what actually happens is this column gets taller, and what happens to the beams inside is that they have to bend to meet where they've been welded to, which is going to really decrease the strength of these steel beams. So what engineers do instead is, instead of just welding these connections, they make them hinged so that the beams stay straight so that they maintain their structural integrity.